Output surface boundaries is used for exporting formation level information to machine control systems. It has other uses, but I think the best thing is for me to demonstrate an exercise to you. What we have in this survey are surface features which have been given a depth. So we have BLDG there with a depth of 0.650 meters, grass at a depth of 0.25 meters, and tarmac at a depth of 0.65 meters. These depths are defined in the Configure Legend surface feature area. I'll select the building first. You'll see that that has a depth there. And if we draw a section through these various surfaces and turn on the surface heights and depths, we will see the building, the grass area, and the main carriageway, each with its own particular surface depth. When we export to machine control and we have two surfaces which join each other at different depths, what we can't do is output 2 points, one at the depth of the building and one at the depth of the grass, because the machine control equipment won't allow us to have 2 points at different heights on top of each other. If we wanted to export the formation level for each of these two separate surface features to a machine control system, we would either have to export each surface individually, or we need to create a additional link just inside the boundary for each surface so that we don't end up with a vertical line between these two differently heighted surface features, because the machine control systems wouldn't handle 2 points one on top of the other. The proposal is, with this output surface boundaries command, that we place a link just inside this surface at the formation level, and then one just inside this surface at its formation level. And yes, we're going to end up with a very steep slope between the two, but at least it won't be vertical. We select Output, Surface Boundaries. We're going to put the boundaries into the current survey, so we don't need to define a load file. I can select individual surfaces, and to select each one I hold the Control key down. So I'm just selecting the ones that have a depth. The default offset from the edge of the surface to where this line's going to go is 5 millimeters, but that can be as large or as small as you want. And normally I would use the LDUM feature. If your surface is on a very steep slope, then when it comes in 5 millimeters, you'll want it to get the terrain level rather than just the same level as the edge of the surface. For these surfaces it won't make any difference. It is now reported that due to the shape and size of these various different surfaces, one point has fallen outside of the surface. There are 49 thin triangles which have been ignored during the creation of the lines inside the surfaces, and 1092 boundaries didn't have existing links. And there'll be triangle sides where surfaces join, but you don't have an actual link feature there. We'll save and load. And if we now zoom in to a small area, zoom right in, this link is the building line, and this is the 5 millimeter offset output surface boundary line on the inside of the building, and this is the one on the inside of the grassy area. Please note that these lines are at the current ground terrain levels and not yet at the formation level. What I'm now going to do is select the output survey command, and I'm going to adjust the levels for the surface height and depth. Now the option perpendicular to surface will be of particular interest to those people who want to create fixed thickness surfaces on slopes, such as clay liners for landfill sites, and this will apply to relatively steeply sloping areas, but where you don't want a vertical height, you want a perpendicular to the slope height. So we may as well choose that option in this case, because this grassy area does have quite a few steep slopes on it. A few messages will appear during this process. If we zoom into this area here, don't worry about all the crosses and white lines. It's because I've used a different prototype for this survey than the original urban one. But if we draw a section for the formation level, which is going to be in red, and the original urban survey in blue, turn off the surface depths, you will now see this is the original ground level surface, and the red line is the formation level model, and you will see here that we've chosen perpendicular offset for these grassy areas. If we return to the original surface area and output survey, but this time we don't choose perpendicular to surface. And this time draw a section through this survey, the original formation level model, which had the depths perpendicular to the slope, and then the original urban survey in green. If we just look at a small area of this, the green is the original ground level survey, blue is the perpendicular formation level offset, and red is the vertical offset. You can see the difference it has to the formation level depth calculation on steeply sloping areas. It has no effect in the flat areas.